Hello everyone, welcome back to the Backend Masterclass. In the previous lecture, we have implemented the login API to authenticate user and return an access token to the client. However, until now, all of our API don't require any kind of authentication and authorization yet. As you can see here, I'm using no authorization in this list account request, but it's still successful, which means anyone can actually see all existing bank accounts in the system, even if they are not the owner of those accounts. So it's very bad, right? What we want to achieve is to add a better token-based authorization layer to the API, where users must provide the access token via the authorization header of the request like this. Then the server will validate this access token and will only return the list of accounts that are owned by the corresponding user. For example, in this case, the access token was generated for user Alice, so the list account API should only return the account owned by Alice. All accounts that belong to Bob or other users should not be returned. Basically, all of our API except the create user and login user must be protected in the same manner, especially the transfer money API. Right now, we can freely transfer money between any account. What we want to achieve is users must provide the access token in order for this transfer money API to go through. And if the access token belongs to Alice, then she can only send money from the account that belongs to her. Or in other words, the from account should belong to Alice. She should not be able to send money from the account owned by Bob or other users. Like what we are doing here is a scenario where Alice tries to move money from Bob's account into her own account. This must be completely prohibited. Okay, so that's what we're gonna do in this lecture. We will learn how to implement a gene authentication middleware to authorize API requests. But what is a middleware and how does it work? Well, it's pretty simple. Basically, the client sends a request to a specific API route on the server. The request will go through the middlewares first, such as the logger middleware or authentication middleware. They're basically very similar to the handler functions that we've implemented in the previous lectures, in the sense that they also accept a single gene.context input argument. The only difference is that within the middleware, we are able to abort the request and send the response to the client without forwarding it to the real handler function. For example, in the authentication middleware, we can parse and check if the access token is valid or not. If it's invalid or expired, then we can call context.abort to stop the request and send 401 unauthorized status code to the client. Else, if the token is valid, we can store the parsed token payload in the context, then call context.next to forward it to the real handler, or possibly the next middleware in the chain if it's available. The real handler will read the token payload from the context to know which user is calling, and based on that information to know which action can be done by this user, and what data can be returned to the client. Alright, so now you know how middleware works, let's jump into coding to see how to actually implement it. First, I'm going to create a new file, middleware.go, inside the API package. Then let's declare a new function, auth_middleware, which takes a token maker interface as input argument and returns a gene.handler function as output. So this function itself is not the middleware, but actually just a higher order function that will return the authentication middleware function. As you can see here, the gene.handler function type is a function that takes a context as input. So I'm going to return an anonymous function with the same required signature here. This anonymous function is in fact the authentication middleware function that we want to implement. In order to authorize user to perform the request, we first have to extract the authorization header from the request. So let's declare a constant, authorization header key at the top. Then in this function, we get its value by calling context.getHeader and pass in the authorization header key. If the authorization header is empty, or in other words, its length is 0, then it means that the client doesn't provide this header. In this case, we create a new error with this message: authorization header is not provided. Then we call context.abort with status JSON. This function allows us to abort the request and send a JSON response to the client with a specific status code. In this case, we send a 401 unauthorized status code and the error response body with the error we've just created to the client. then return immediately. If the authorization header is provided, then it should be of this form: a bearer prefix followed by a space and the access token. The purpose of this bearer prefix is to let the server know the type of the authorization, because in reality, the server might support multiple types of authorization schemes, such as OAuth, Digest, AWS Signature, or many more. Okay, so here we should call string.fields function to split the authorization header by space. We expect the result field to have at least 2 elements. If it doesn't, then we return an error, invalid authorization header format to the client. Otherwise, the authorization type is the first element of the field slice. Here we use string.toLower to convert it to lowercase to make it easier to compare. Let's say at the moment, our bank only supports one type of authorization, which is bearer token. So I will declare a constant for the authorization type bearer. Then here we compare the authorization type with authorization type bearer. If they are different, then we should return an error to the client, saying this authorization type is not supported by the server. In case the authorization type is indeed bearer token, then the access token should be the second element of the field slice. Now it's time to parse and verify this access token to get the payload. We call tokenmaker.verifyToken and pass in the access token. This function returns a payload and an error. If error is not nil, we just return unauthorized status code with the error itself. Otherwise, the token is valid, so we should store the payload in the context before passing it to the next handler. To do that, I'm going to create a new constant, authorization payload key. The payload value will be stored in the gin context with this specific key, so that later in the handler function, we can easily take it out using the same key. Okay, now to store the payload to the context, we just need to call context.set and pass in a key value pair. In our case, it is authorization payload key and the token payload itself. Then the last step is to call context.next to forward the request to the next handler. So that's basically it. The auth middleware is completed. There's a warning here because this middleware function is unused at the moment. It will be gone once we add the middleware to the server. But before doing that, let's write some unit tests for this authentication middleware. I'm going to create a new file, middleware test.go, inside the same API package. Then let's add a new function, test_auth_middleware. We take the testing.t object as input. There are multiple cases we want to test, so let's use table-driven test strategy. First, I'm going to list out all of the test case with this anonymous struct. Each test should have a name of type string. A setup auth function to set up the authorization header of the request. This function should have 3 input arguments: the testing.t object, the HTTP request object, and the token maker interface to create the access token. Each test case should also have a separate function to check the response. This function will take a testing.t object and a HTTP test.response recorder object as input. Okay, so that's how the test case struct looks like. We will come back to add the actual test cases later. Now let's iterate through the test case slice and store the current test case as a tc variable. We call t.run function to generate a subtest. Pass in tc.name as the name of the subtest, and a function with testing.t object as input. This function contains the main content of the subtest. So first, we create a new test server using the new test server function we wrote in the previous lecture. In this middleware test, we don't need to access a store, so here I use nil for the db.store parameter. Next, we will add a simple API root and handler just for the sake of testing the middleware. Let's say the path is /auth, and we declare the root with server.router.get with the auth path, then create the auth middleware with the server.tokenmaker and add it to this root. Finally, the handler function, which takes a gin.context object as input. To be simple, in this function, we will just send a status 200 OK with an empty body to the client. Okay, now the API is added to the server. Next step, we will send a request to this API. Let's create a new HTTP test recorder to record the call. Then create a new request with http.newRequest function. The method should be get. The path is auth path, and the request body is nil. We require no errors. Then we call tc.setupAuth function with t, request, and the server.tokenMaker to add authorization header to the request. After that, we call server.router.serve_http with the response recorder and the request object. Finally, we call tc.checkResponse to verify the result. Okay, now let's go back here to add the test cases to this table. The first case is a happy case, so I'm going to name it OK. Then let's copy these two function signatures to this case. For the setupAuth function, what we need to do is to create a new access token and add it to the authorization header of the request. As this step will be used in multiple cases with different configurations, I'm going to create a separate function to do that. Let's call it function addAuthorization, which takes following input argument. First, the testing.t object. Second, the HTTP request object. Third, the token maker interface. Then the authorization type string, the username string, and finally the duration of the access token. In this function, we create a new token by calling tokenmaker.createToken with the input username and duration. Require no errors. Then we create the authorization header value with this string format. It should be two string values separated by a space. The first string is the authorization type, and the second one is the access token. Now we set the header of the request using request.header.set function, passing the authorization header key constant, and the authorization header value we've just created. And that will be it. Now let's go back to the test. In this happy case setupAuth function, we just call addAuthorization with the following argument: t, request, token maker, then the authorization type bearer constant, any username, let's say user, and the token valid duration, let's say 1 minute. In the checkResponse function, we just require the recorded response status code to be 200 OK. Now I'm going to duplicate this case to make the second one. Let's say this case is no authorization, which means the client doesn't provide any kind of authorization header. So I'm going to remove this addAuthorization call. And the expected response status code should be 41 unauthorized. The third case we want to test is unsupported authorization. As I said before, it's possible that the server can support multiple types of authorization. In Postman, you can see a list of authorization type here. In our case, we choose bearer token type. So basically, Postman will add an authorization header with prefix bearer and the access token suffix to the request. Now for the unsupported authorization type, we call addAuthorization function just like in the OK case. But this time, instead of passing in authorization type bearer, we will just pass in unsupported as the authorization type. And because of this, the expected response status code should be unauthorized. The next case we want to test is invalid authorization format. Let's say the client doesn't provide the authorization type prefix. So here I just pass in an empty string as the authorization type. And the expected status code will still be 41 unauthorized. The last but very important case is when the access token is expired. In this case, we will send the correct authorization type bearer, but with a negative token duration. Let's say -1 minute. By doing so, the created token will always be expired. So the response status code should also be unauthorized, as in the other failure cases. Alright, now I think all the cases are declared. Let's run the test to see how it goes. Cool, all of them passed. Let's try running the whole package test to see the code coverage. In the middleware.go file, you can see that the whole auth middleware function is covered. So that's how you unit test a middleware. Now as we have confirmed that it's working well, let's add this auth middleware to the server. I'm gonna open the API server.go file. We will add the new middleware to the server in the setup router function. The create user and login user root don't need any kind of authorization because we want everyone to be able to freely create a new user and login. All the other APIs, on the other hand, must be protected by the auth middleware. To do that, I'm going to create a group of root called authRoot using the router.group method. This slash is the path prefix of all roots in this group. And we call .use function to add the auth middleware to the group. We pass the server.tokenMaker interface to this higher order function that creates the auth middleware, just like what we've done in the unit test. Now for all the remaining roots, instead of using router, we will use authRoot to add them to the group. By doing so, all of the roots in this group will share the same auth middleware that we've just added to the group before. So basically, every request to this root must go through the auth middleware first, and that's exactly what we want to achieve to authorize the API request. Now a lot of our API unit tests will fail because of this change. For example, if we run the test get account API, it will fail because the API is now returning 401 instead of 200. In order to make this test pass, we will have to add authorization header to the request, like what we've done in the middleware unit test. But before doing that, there's something more important we must do. Keep in mind that all the auth middleware does is only authenticating the request, which means that it only requires the client to provide an access token in order to pass the request to the real handler. But it doesn't care if the user who owns the token really has enough permission to perform the action or not. This important part, which is still missing, is called authorization. Authorization is often API specific, or in other words, the authorization rules are different for each API. So normally we would implement the authorization logic inside each of the handler. For example, in the create account API, we don't want a user to be able to create an account that belongs to other user. The rule is, a user can only create an account for him or herself. So here we should get rid of the owner field of the create account request struct. The owner should be the username of the login user stored in the authorization payload. Therefore, in this create account handler, we will get the authorization payload by calling context.mustGet and pass in the authorization payload key constant. Note that this call will return a general interface. So we have to cast it to token.payload object. Then here, the owner field of the create account param struct should be changed to authPayload.username. Just like that, we've just added authorization to the create account handler. Next, let's move to the get account API. The authorization rule for this API is simple. A user should only be able to get the account that he or she owns. So similar as before, I'm going to copy this statement to get the authorization payload from the context. Then before returning the account to the client, here we should check if the account.owner is the same as the authPayload.username or not. If they are different, then we will create a new error. Account doesn't belong to the authenticated user. Then we send this error with the HTTP status code unauthorized to the client and return right away. And that's it for the get account API. How about the list accounts API? Well, as I said at the beginning of the video, a user should only be able to list all accounts that belong to him or her. In this case, our SQL query doesn't support filtering accounts by owner yet, so we have to update it first. In the list account query of the account.sql file, I'm going to add a condition where owner equal to $1 and change the parameter index of limit and offset to $2 and $3 respectively. Then let's run make SQL in the terminal to regenerate the Golang code for the list account function. Let's also run make mock to regenerate the mock store for our API unit test. Now go back to the code. Here in the account.sql.go file, we can see that the list account query has been updated, and a new owner field has been added to the list account param struct. This change will break our DB test of the list account function. So let's open account test.go file to fix it. In the test list account function, we are creating multiple random accounts, each associated with a different random user. So to make it simple, I'm just gonna filter by the owner of the last account. I will declare a last account variable to store the information of the last generated account in the for loop. And here, we just assign the create random account to the last account variable. Then I will add the owner field to this list account params object. Its value should be the last account.owner. And since each account belongs to a different random owner, there won't be many accounts with the same owner as the last account. So we should change the offset to 0 instead of 5, so that we will have at least one record in the result list. Then here, instead of require the list to have 5 records, we just require it to be not empty. And in this for loop, we will add one more check to make sure that the result account owner is the same as the last account owner. Okay, let's run this test. It passed, so we're good now. I'm going to close all of these files and go back to the API account.go file to add authorization logic to the list account handler. Same as in the create and get account handler, I'm going to add a statement to get the authorization payload from the context. Then let's add the owner filter field with value of payload.username to the list account param struct. And that should be it. We've just added authorization rules to all of the account management APIs. The only remaining API that requires authorization, and also the most important one, is the transfer money API. The rule is that a user can only send money from his or her own account. So basically we have to compare the owner of the from account with the authenticated username. To do that, we must have the from account object in the handler function. So I'm going to add db.account to the return value list of the valid account function. And we have to add account to all return statements inside this function. Okay, now go back to the create transfer handler. Here we will store the result of the valid account function call in the from account and valid variables. If the account is not valid, we just return as before. We do similarly for the to account ID. But we don't need to store the account object in an actual variable because we don't need it for the authorization rule. So I just use a underscore here as a placeholder. Now for the authorization logic, we first get the auth payload from the context just like in other APIs. Then we check if the from account.owner equals to auth payload.username or not. If they are not the same, then we create a new error. From account doesn't belong to the authenticated user. And we just send this error to the client with status code 41 unauthorized. And we should remove this colon because valid is not a new variable. And that will be it. The authorization logic is now added to all of the required APIs. Now it's time to update our API unit test to adapt to the new authentication middleware and authorization logic. First, the test get account API. At the moment, we're generating a random owner inside the random account function. But to make it easier to test the authentication and authorization logic, I'm going to change this function a bit. It will take the owner string as input and use it as the account owner instead of generating a random value as before. Now in the test get account API function, we first call random user to generate a random user. Then we pass that user.username into the function to generate a random account. Okay, now we will do similar to what we've done in the auth middleware test. Let's copy the setup auth function signature and paste it to the test get account API test case struct. Then also copy the implementation of it for the OK case. This time, instead of using a constant string as username here, we must use the account owner's username, which is user.username. This setup auth function should be added to all of the existing test cases. Then in the main body of the test, before calling server.router.serve/http, we should call tc.setupAuth with parameter t, request, and server.tokenmaker. And we're done. But before we can run the test, we should fix all errors in other unit tests. So let's copy these two statements from the test get account API and paste them to this test create account API function. For the test list account API, let's say we will use the same user for all accounts. So let's just create the user at the top of the function, then use that user's username for all accounts inside the for loop. We still have errors in the transfer test.go file. In this test transfer API, we have 3 different accounts. So let's create 3 different users for each of them. To create account 1, we pass in user1.username. For account 2, we pass in user2.username. And similarly, account 3's owner will be user3.username. Alright, now all errors are fixed. Let's run the getAccount API unit test. They all passed. Awesome. Now to make it more robust, I'm going to add some more test cases to the list. First, the unauthorized user case, where we use a token of a different user who's not the owner of the account. Let's say the username is unauthorized user, for example. In this case, we expect the response status code to be http://status_unauthorized instead of OK. And we can remove this required body match account check. Let's add one more case, no authorization. In this case, the client won't provide the access token to authenticate the request. So we will remove this add authorization function call. In this case, the request should be aborted in the authentication middleware, so it will not reach the handler. Therefore, in the build stub function, we should expect the getAccount function to be not called at all. To verify that, we just need to change the second parameter of the getAccount stub to gomock.any. The number of times JIT function should be called to 0. And remove the return account call here. The expected response status code will be unauthorized as in the previous case. Okay, now let's run the test getAccount API again. All passed, including the 2 cases we've just added. Okay, so now you know how to update the getAccount API unit test to satisfy the new authentication middleware and authorization logic. You can apply the same method to update the rest of the API unit test for the create account, list account, and transfer money API. I leave that as an exercise for you to practice. And if you want to take a look at how I implement them, feel free to check out the GitHub repository of the course. Now before we finish, let's start the server and send some real API calls in Postman to see how it goes. First, let's try this list account API. We've got 401 unauthorized status code because the access token we used in the beginning of the video has expired. So let's send this login request to get a new one. Okay, it's successful, so I'm going to copy this new access token. Go back to the list account request, open the authorization tab, and paste in the new access token in this box. Then click send again. This time the request is successful, and look at the response data. We have a list of 3 accounts, all belongs to Alice. So that's exactly what we want to achieve. Alice can only see her own account. She can no longer see the accounts of other users as before. Now let's try the transfer money API. First, I'm going to try sending money from Alice's account to Bob's. So the from account ID should be 1 and to account ID should be 2. Let's send the request. Token has expired. This request is still using the old access token. Let's change to the authorization tab and paste in the new one. Then send the request again. This time it succeeded. $10 has been transferred from account 1 of Alice to account 2 of Bob. Okay, now let's see what will happen if you try to move money from account 2 to account 1. This is a case when Alice tries to steal money from Bob's account into her own account. As you can see, the request is prevented. We've got 401 unauthorized status code because the from account doesn't belong to the authenticated user. So the transfer money API is very well protected by the authentication middleware and authorization rules. And with this, I'm going to wrap up this lecture here. You can try calling the rest of the APIs on your own if you like. I hope you enjoyed the video. Thank you for watching. Happy learning and see you in the next lecture.